Zdravo svima još jednom. As Dragan mentioned, today I will present some of the results considering the impact of heat wave on hospitalization and mortality too in Serbia, particularly mostly in urban areas in our country. Also, we will say something generally about this topic. How population and climate are actually connected. Climate have influence on economy for social aspect and on human health too. And both of these have impact on population well-being. In our research group, we investigate mostly, actually only aspect, it's human health using mortality data, and from recent period also data about hospitalization. Relation between climate and mortality is recognized for a very long time. We can say since the period of Hippocrates, and that relation are well established. Association was founded with both hot and cold periods, usually forming V or U shape in mortality pattern. It's widely recognized that both hot and cold periods have impacts, but in our research we split these two effects in long-term and short-term impacts. What we mean when we say long-term impacts of temperature related mortality or hospitalization, we mean on some seasonal change over 1 year or some longer time series. And when we said short term, then we think about heat wave periods or some other, or cold wave periods or some other extreme events which are happened in few days, for example. But generally, both of these could and have some long-term impact on population stroke mortality or some specific causes of disease. Until now, all findings are well established impact of extreme climate conditions during the summer, and how they may constitute minor public health threat, increasing the health risk during the heat hazards. One of the most pronounced, actually two of the most pronounced heat hazards are Chicago heat wave in 1995 and 2003 heat wave in Europe, where during that heat wave, much of Europe was affected with extremely high temperature during the first half of August. Most of the countries who were hit with this heat wave are countries in Western and Southern Europe. France was one of the countries with the highest excess mortality during the period between 1st and 15 August 2003. What excess mortality means, it is a difference between observed and expected number of deaths. As you can see on this graph, the number of dead in first half of August in France was much higher compared. It's a black line on the graph, and the gray line are some historical baseline period as a reference period. The observed number of dead was more than double higher compared to some previous years. Excess mortality in France in that summer was for 55% higher than usually. Almost all region, not almost all region in France experienced increase in mortality, and that increase was between 25 and 100%. Situation like this are not very frequent in population history. We can compare this hazard, for example, with in relative numbers with hazards during the World War II or Spanish flu, or now recently we had a COVID situation when in some months we had double higher number of dead than it was expected. So the 2003 heat wave was one of them that could be compared with these historical events. Similar to France, other countries like Germany, Spain, Italy, Switzerland also experienced a similar increase in excess mortality during this heat wave. Portugal was also affected with more than double higher number of deaths during the first half of August. And why I mentioned Portugal apart the France, because after this heat wave, they government developed a health warning system to reduce and prevent such a human hazard like it was in this 2003. If we consider data for Serbia, and the results published and unpublished results for Serbia in relation between temperature and mortality. Until now, we have a few papers who are mostly dealing with seasonal change in mortality. So they treat all 4 seasons during the year and mostly winter ratio. Only a few of them are considered particularly some summer period or heat wave period or some days with extreme extreme temperature during the summer. A few studies were conducted for Belgrade, treating the heat wave, and one for Novi Sad. This for Novi Sad was, it is our study. We treat summer 2050. Summer 2050 in Central Europe was categorized as one of the most severe summer with extreme hot and dry conditions and increase in extreme events like heat waves. And it was one of the most severe summer comparing the last few decades in the past. And similar magnitude of warning was similar like those heat wave in 2003. So in order to assess the impact of this heat wave, we use the data for Novi Sad, temperature data and mortality data too. Temperature data was provided from our network station located in the urban area. And mortality data was provided by Institute for Public Health of Vojvodina. They are official representative for collecting this data. So the data was under all a process of checking checking all informations, and it could be treated well. So, in order to assess, firstly, when we examine impact of a heat wave or some other extreme temperature event on mortality, what we should do? We should first find what in which day heat wave period occurred, or some other extreme temperature event. So we define heat wave. It's a methodology applied already on some other cities in Central Europe, where we use 3 continuous days when maximum temperature was at least 30 or more degrees. And we defined 4 heat waves in summer 2050, 1 in June, 2 in July, and 1 in August. July and August were characterized during this summer with extremely high temperature, and days with maximum temperature 30 or more degrees counts about 45%. So almost half of the day in the month was characterized with extremely high temperature. On this data, we applied mortality data. Mortality data was applied for all causes of mortality. That is total number of dead. Also, as we have finding that certain specific causes of death are more likely to be under impact of heat waves. That are cardiovascular and respiratory diseases. We treat these two causes additionally, and also we analyzed these two categories for population 65 and over. That is all population, and population below this age limit. We use the regression analysis and test number of dead in all these categories in days with heat wave periods against the day without heat wave period. And we found a statistical significant increase in mortality in all days during the heat wave periods. We didn't find statistical significant difference, statistical significant increase in mortality for population below younger than 65 years. So that is a young population and working age population. There were no statistical increase in mortality, but for all population, there were. Also, in order to exclude other causes of disease, we tested also mortality, other causes without where we excluded cardiovascular and respiratory mortality, and also other causes didn't show any statistical significant increase. So we can, on this data for Novi Sad, we can say that people with already pre-existing cardiovascular disease or respiratory chronic disease are under a strong impact by heat waves or other extreme temperature events. On this graph, you can see data from the table showed how all causes mortality and specific causes mortality increase with when temperature starts to increase. Red lines marks interval of trust, and we put it on 95%. So all categories except other causes of disease and working in younger population were treated with this heat wave. Additionally, for the same summer in 2050, we, in our research group, we applied, developed impact level, risk impact level using temperature and mortality data. A few years ago, Urban Climate Research Group implemented a concept of local climate zones for urban area of Novi Sad, defining 7 LCZ in urban area and 1+1 in heavy industry. So on this maps, you can see yellow map are the locations of are defined local climate zones, and on red are impact level of these local climate zones. We have local climate zone is the most built up area, most settled with a low level of green infrastructure. While, for example, LCZ6 are more middle area with with not so high temperature risk level like LTZ2. On this data, we applied mortality data by districts in urban area. And we found it a very interesting thing, that is fact that in LTZ2, that's our area with red line marked, lives about 60,000 people in Novi Sad, and while, for example, in LTZ6 lives about 1,800 people, and LTZ6 have higher share of older population, but share of mortality in older population was higher in LTZ2, which we explain with high LTZ2 is under higher temperature risk level. It is categorized with a very high and high risk level, while LTZ6 is categorized with medium and low risk level. And LTZ6 have a higher percent of area with green infrastructure, while in LTZ2 this area is on a small level. Recent findings confirmed that green infrastructure would significantly impact human population, particularly in urban area where we have high built-up zones. Similarly to this research for Novi Sad, scholars from University of Belgrade had investigated impact of heat wave in 2007 for urban population in Belgrade, and they also found it in the middle of summer in July, strong increase in cardiovascular and respiratory mortality. According to our unpublished data for Novi Sad, we also found that the excess mortality difference between expected and observed number of deaths in Novi Sad in July 2007 was about 35%. So that means that the observed number of deaths in Novi Sad was about 35% higher than it would be expected. And we can say that this summer was also severe for population in our country, but also in other countries of Central Europe. During the work on this project, Extreme Heat in Serbia, we collected data for 5 municipalities, or some of them are called cities: Belgrade, Novi Sad, Niš, Vranje, and Loznica. We collected daily data about temperature, air temperature, and mortality data, all causes. Also, we collected the data by gender. On this graph, you can see air temperature during the summer period in all 5 cities for the period from 2001 until 2050. On all 5 graphs, you can find some outliers that are 2003, 2007, 2012, and 2050. That means that in this year, summer were characterized with very high temperature and intensive temperature extremes like heat waves. On this data, we applied mortality data, and we found it. So this is preliminary data, so still maybe it's not interesting for the picture, but I will explain you. On this data, we applied using a Poisson regression. We applied mortality data, and we found statistical significant increase when temperature starts to increase during the summer. Mortality also starts to increase. Differences in each city was founded only in case of lag structure. In some cities, there is no lag effects. Its effects is immediately, but in some cities, a lag structure varies between 1 and 2 days. So that means if it today is a strong heat wave, human body react 2 days after the first day. Generally, for summer temperature and mortality, lag structure vary between 0 and 3 days mostly. In the winter period, this lag structure could be extended until 21 days, mostly until 14 days. But during the summer, 3 days is the maximum. So here we still didn't investigate why we have a different lag structure. We can suppose that it depends on type of urbanization, location, or geographical location, and some urban microclimate conditions of each city. Also, for this data, we found that a difference between male and female. Differences between genders were founded in that sense that male population were more affected, and these differences we cannot explain only with the impact of summer temperature. Also, they depends on life expectancy. Female are live longer with the different socio-demographic factors, but also most important are lifestyle factors. So they could affect in high percent these differences. Similar to temperature-related mortality, we start to investigate and relation with hospitalization. For this purpose, we provided data. It is very difficult to provide data about hospitalization, particularly on daily level, which is most important for assessing heat-related mortality or hospitalization. We provided daily data about hospitalization for Novi Sad from Institute for Public Health of Vojvodina, and for temperature characteristics, we use one urban station located in Novi Sad. It is a station named 2.2. It is a station, I think, located in at the Grbavica district in our city. And what we measure here, we use total number of persons who are treated under hospitalization. We use number of persons with hospitalization who are older than 65 and younger than 65. We also analyze the number of hospitalization by causes of death, by cardiovascular diseases, some subgroup in cardiovascular diseases, respiratory diseases, neoplasms, and external causes. External causes are causes like injuries, poisons, or other type of the disease. They are not chronic disease or traffic accidents or something like that. And we use what type of data? We didn't use a maximum temperature. We didn't use minimum temperature. We use temperature change in neighboring days. So when temperature one day fall from very high to low or in opposite direction, then we start to observe number of persons who were under hospitalization. And what we found that people with cardiovascular disease are under the high risk with lag structure from 1 to 2 days. And what we found also important is that older persons were not under high risk, which is opposite to results for mortality. And why is that? In this preliminary data, we found that people younger than 65 are under more higher risk. Why? Because this is not mortality, this is hospitalization. Older persons are usually retired and they are in their homes. People younger than 65 are working age population. They travel to the work and back. They need to go to pick up children in kindergarten. They are during the heat wave period. They are exposed to direct to the environment, or their job is related to some open space and heavy temperature risks during the heat wave period. So that's the reason why they are under higher risk during the summer period compared to the older person when we consider hospitalization. Okay, I have a few minutes more. I can speak all day about this, but it's so. Fifth assessment for climate change in 2007 gives some review about the projection of heat-related and cold-related mortality, and they conclude that heat-related mortality, so the increase in summer mortality due to extreme heat wave periods in future will be more severe, and heat wave periods will be more frequent, and the risk in excess mortality will be higher compared to the winter or other parts of the year. Similar to these projections, also one research group led by Antonio Gasparini from England, using 4 different climate change scenarios, calculate increase in heat-related excess mortality and cold-related excess mortality. And in case of some, they use 3 climate scenarios. In one of them, where they predict a strong increase in average yearly temperature, increase in greenhouse emission, change in air pollution. For Central Europe, and which is most interesting for us, they predict very high increase. It is a red line on the graph in the middle of slide. Strong increase in heat-related excess mortality and decrease in cold-related excess mortality. And this is very interesting signs that cold-related excess mortality during the winter period always was, always had and have still increasing trend. So in the future, if we do not take care better about our nature, we will be faced with the most severe and extreme heat events, which will give us more excess death. So what would be some, not solution, but some proposal for prevention of these hazards? Firstly, we should calculate projection, measure projection for sub-regions. These are projections on global level, but since we are treating urban microclimate mostly, we should calculate the projections on sub-regions, and then according to that projections, think about if there is need to develop a health warning system, which may give us alert in order to mitigate negative effects of extreme temperatures during the summer periods, and mitigate negative effects on public health and human population. particularly in the cities. Why we always that highlighted? Because the most of population in our country, as well as in all other countries, developed countries in the world, lives in urban areas, and that's urban areas are the places with positive net migrations, and they will be in the future. So they are most affected places in relation with temperature and hospitalization and mortality too. Okay, with this slide, I will finish my presentation, and if you have any questions, please do not hesitate to ask.
Okay. So you can choose the tab or the one. Thanks to Daniela for a great talk. You can see that with Daniela, she's very, let's say, brutal. Statistics don't lie. You have excess mortality, so heat can kill you, yeah. Or if you're over 65, so luckily under 65, there is no significance. Statistics are there, but the younger can be hospitalized. Yeah? So you saw the data is there, it shows. So we have a short question. I saw that we have a colleague, Michael Allen, our colleague from USA. So you can see this is really international. And Mike is actually, he has one question from Daniela. I think you will have a short answer because the question is quite straightforward. So defining heat waves, maximum temperature certainly offers interesting results. But Mike is curious if there is any work on minimum temperature done here in Novi Sad. Research shows that nights where temperatures don't cool sufficiently are more deadly, and these temperatures are often warming more rapidly than the daytime temperatures. By the way, excellent presentation. So is there any research for Novi Sad with the minimum temperature?
Hello, again, no, still we didn't investigate minimum temperature, and we didn't investigate night time, but we know that there is effects of hot nights on population too, but still we didn't use that indicators in our research. But I'm sure we will in some upcoming days.
Okay, thank you. Yeah, I think we will, especially because our colleague Mike, next semester he will join us. So he got Fulbright to go to Serbia. Usually it's the other way around. So you apply to go to USA, but you see Mike wants to work with the urban climate research team in Novi Sad. So you will meet him next summer. He will be here for the semester, teach you, but also show you some methods that he uses. And I guess Mike will be interested to do this research with us. So, yeah.
I would be glad to cooperate.
Yeah. Mike, if you have something to add, please do it. If not, then we will continue. Okay, I will now stop.